Okay, enough of me talking. I'd like to now introduce to you officially Ryan Betts, who is our VP of Engineering, and he's going to be coming on in a second, and he's going to be talking about what they've been up to in engineering. Ryan, can you hear me?
I can. Thank you for the introduction, Chris.
You
Uh,
sound
so,
great. I'll let you take it away.
thank you. Gosh, thanks everyone for joining us at Influxdays. And I guess while I'm introducing myself here, let me just say that that's not what I intended to do. Let me understand why I'm not seeing the slide I expect to see. Okay, sorry about that. So while I'm introducing myself, let me just say that speaking virtually isn't super easy for me, but I really appreciate how easy Chris and Caitlin and all of the other organizers of Influx Days have made it. We are not an easy group to corral as speakers, and they've just done a remarkable job. I wanted to say thank you to them. Let me introduce myself briefly. I'm the VP of Engineering at Influx, or one of the VPs of Engineering at Influx, and I'm responsible for the overall engineering team. But it's really a partnership of engineering leaders, both technical and managerial leaders, and so really a pleasure to have an opportunity to speak to you all, as a placeholder for engineering overall. Personally, I've been at Influx since March of 2017, and just to share a little bit more about me, I live in Massachusetts on the East Coast of the United States. So, good morning and a good afternoon to everyone everywhere who's joined. So, I want to talk about some different things today. I'd like to talk a little bit about what engineering is and who we are. I'm going to talk a little bit about sort of our product set and how we think about it. And I'll share a little bit of detail about what's kind of under the covers in cloud, talk a little bit about how we build and operate our cloud service, and then give an update at the end of the talk on the tech stack and some of the improvements and investments that have been made there. So let me kind of start by talking about something that we don't talk a lot about publicly. But in thinking about how to structure this talk, I know that there are a lot of other teams of builders, other teams of developers out there. And I think we don't really talk a lot about how we build software. I think often talking about how we approach building something is just as important as what we build in many cases, especially if you love software engineering management. And so I thought maybe I'd take some time at the start of this talk to share a little bit about how at Influx we're approaching kind of building our teams and building the products that we use together. The first thing I'd say is that we're really a cultures and values first organization. I've never worked anywhere where I could say that with a straight face before Influx, but it's super true here. We have a set of core values around valuing each other, getting stuff done, believing humility drives learning, or if you're a Darkest Dungeon fan, you might rephrase this as overconfidence is a slow and insidious killer. It's a phrase that always cracks me up when I see it. Embracing failure and our commitment to open source. All of these are really important substrates to the decisions we make, kind of how we approach work, and kind of how we get work done. We are a remote first team. We've been a remote first team for some time, and with COVID have gone to be a fully remote team. And so we have employees from New York to Hawaii in the United States and many states in between. And we have employees in about 10-ish countries. And I realized as I was sort of practicing this slide that my American bias is here and that I'm calling out states versus countries, which I apologize for. We have employees in many states in their countries outside of the United States as well. So I have to forgive me a little bit of my Americanism coming through there. So we have a range of people in our engineering team. I have a handful of PhDs. We have some great people who've come out of coding schools who have tremendous impact on our team. We have people on our engineering team who've been at Influx for, 6, 7 years, and some people who've just started in the last couple of weeks. So we really have a strong range of talent, backgrounds, experience, and we approach a lot of our work with a really shared culture. I want to say that I'm not trying to say by any means that we're perfect here. We certainly have our foibles and our quirks, and we make plenty of mistakes. I use up my mistake quota early every week. but it's a great place. And I hope that that really shines through in the interactions that you see from the engineering team and our Slack channels and our GitHub repositories and in the product itself. So why do I these I apologize, Jay. These slides are coming out of order, and I'm not certain why. Um, so why do we do this is I don't know what's happening with this presentation order. Okay. I apologize to the audience for the confusion. So let me see the next slide. This is not the correct slide. Um, yeah, these are totally in a let me just walk through this, and perhaps in the background someone can help me put the slides in the correct order. So if I yeah, so I wanted to talk a little bit about why we do what we do. So, of course, we all have our own personal motivations that bring us to work. However, as a team, we really have a set of shared motivations about what we're trying to accomplish as a group. And at the heart of that is that we just love building developer tools. Right? So, our goal is to build a time series database that's kind of where you need it and when you need it. That means that you can build whatever the world needs, whether you want to do that on open source, whether you want to do that on premises software, or whether you would like to do that in a SaaS cloud first environment. We also strive to make sure that the tools that we build make it easy for you to build the applications that you want to build. Real-time analytics applications and many time series applications are essentially real-time analytics applications are complex to build. There's a lot of portions that need to be built and managed, and we do the best that we can to make that process easy by providing as much as we can out of the box. That means providing a platform that can have the ingest, query, and alerting capabilities that are required. It means building in real-time operational monitoring, and it means providing a platform for teams of developers. We have a handful of sort of dictates that we work through internally, kind of guide this. So the first is to put builders first. We believe that the people using our platforms should be able to build their applications with less effort, less code, less configuration, and a faster time to awesome than developers who choose to build outside of our platform. That means that we want to provide really thoughtful user journey workflows, meaning great APIs, client SDKs, command line tooling, documentation, and packaging. It also means, going back to sort of being a values first organization, that we need to have a culture that nurtures the community of builders that work with us. That means meeting you where you work, whether that's Slack or GitHub, message boards, meetups, conferences, through our support interactions, training, or at places like this, like at Influxdays. Secondly, we work hard to craft a user experience that puts time to awesome first. All right, we want you to never have to start from scratch. We provide web and GUI tooling that accelerates early processes when building. At the same time, we try to make it easy to look under the hood to see raw code and APIs. You could see very raw code, right? A lot of what we produce is open source and just viewable to you under the covers. We also want to make sure that you can collaborate with teammates. We understand that building things is something that we do with people. And so we try our best to make sure that you can build with groups of people in a way that's suitable. Time series applications are really an ecosystem application. And so it's important that we respect the ecosystem, that just a swath of applications, technologies, industries, databases, big data tooling, message buses, data schemas, different applications that need to be monitored, a whole host of IoT data protocols, many cloud service providers, many different programming languages, lots of different deployment and operational models for your application. And so we do our best to integrate with all of these different systems, try to determine how we can best use the ecosystem around us and be a healthy participant in that ecosystem to enable builders. It's important to us that your applications can scale from your laptop to the cloud. And so we provide software in lots of different packaging formats, from open source to SaaS. And finally, when you build data management tools, earning trust is just extremely important. We understand within our engineering group that you put business critical data sort of in our hands, right? You're exposing your customers, your use cases, your revenue streams, your operational controls, all of that to our services. And it's really important to us to understand explicitly that that we need to earn the trust to do that. And so again, this plays back to being a values-first organization and approaching our interactions with honesty, as well as supporting the formal auditing and things like SOC 2 compliance processes that can further assure you that we take our work seriously and that we take your success seriously. So I want to talk a little bit next about some of the different organizational functions that exist within engineering. So we're kind of firm believers that you end up shipping your org chart where there are team boundaries. You often end up creating software boundaries. And so we spend a fair amount of time wondering and trying to improve the places where we have team boundaries, wondering if we have it right and doing our best to improve it when we can find gaps. But there are a really broad set of functions that sit within engineering. And before I kind of walk through these, I just want to explicitly acknowledge that all of this is only possible within Influx because of the partnership that we have with our product managers, our support teams, our documentation and technical writers, and communication architects, our designers, and our analytics teams and our sales engineering teams. So really within Influx, I try to think of engineering as really this broader set of people, all of whom are extremely accomplished at building things. Let me kind of walk through just kind of what's within the formal engineering organization itself. So within engineering, we have our developer relations group. This is just of critical importance to us. So Anais, Michael, Jay, Popey, Zoe, all of them, I'm sure you see them throughout our community. They're really sort of our eyes and our ears, and in many cases also our mouths. They have a great knack for figuring out by listening and working with you what's maybe harder than it should be, and then also being able to explain solutions back to the community. If you don't follow the TLDR blog series that's produced, for example, you definitely should. I learn a lot about the products we build from that series. There's just great content there. Also within engineering, we have an operational function that's responsible for the low-level operations of our cloud service, as well as our managed database offering provides a large set of operational capabilities to the support team, which is really the primary operator of that team. We have teams for the tech stack components, and engineering is responsible for tier 3 support. So in cases where support either doesn't have the sufficient enablement from us to answer a question, or has an unusual question or a defect that's been found by a user, those cases end up elevated to our engineering team and are processed there. Then within our cloud engineering organization, we have teams that are responsible for users and billing and marketplaces. Of course, we have teams responsible for core storage in the shape of IOX and our TSM storage tiers. We have a team that's responsible for query like Flux and InfluxQL technologies, Scrum teams for UI and development tools, as well as a team that's extremely important to us, I'll talk a little bit about later, for internal developer ergonomics. We call this our deployments team, and they're responsible for making sure that developers at Influx can get code from their laptops all the way to the cloud service. So that's just a little bit about kind of who we are within engineering. And I hope that's not too much detail. I hope it's of some interest. Thought maybe I would take a moment to share a little about that, as it's something that often doesn't get talked about, but I think is really quite important. So next, I'd like to talk a little bit about what InfluxCloud looks like under the covers. And before I can do that, I really want to talk through sort of first what you as a user see and how we think about some of those different external tools, and then try to map that a little bit to the internals of the product. So what users see primarily are the UI through the browser-based web UI, or a UI through VS Code, or a user interface through the CLI, as well as a set of client SDKs, and finally our JSON-based resource API. And so let me kind of walk through these different tools and talk about what we aspire them to do for users and who we build them for specifically. If we look at the browser-based UI, this is really our most fully featured user interface. Thank you so much. In the background, I see the slides have caught up with me. I really appreciate that. So the browser-based UI primarily today exists for developers, but over time will be extended to include tools that you need to operate and manage your application within the cloud product. And so about a year ago, we realized that a lot of the development paths within our UI sort of resulted in dead ends, right? So you'd be using part of the product and you'd have to sort of guess how to connect what you had just configured or built sort of into the next stage of your workflow. And so we've done a lot of work to try to improve that. And we've built some tools that we think are foundational to continuing those improvements. And so the first of those is a notebooks tool. So our notebooks effort is started sort of as an internal passion project in engineering. It's a feature that really came from engineers as they used the product, tried to figure out how we could make the UI better for developers. Our goal for the notebooks experience is essentially to produce like a visual REPL that you can use to build the queries and the dashboard cells or the tasks, and that you can then sort of export the configuration and code that you've written into the different resources where it needs to be. So for example, you can pull open a notebook, you can explore data, you can interact with that data, then you can write a task or an alert, and then you can export the content of that into that task or that alert, right? And use the notebook as sort of a primary authoring experience that allows you to combine exploration, navigation, learning, and then the final authoring and configuration. We also, as Tim had mentioned yesterday in his talk, right, see people use notebooks simply as a scratch pad that they'd like to return to. This is another important feature. Once we're satisfied that we have a sort of core builder experience within cloud that we really love and that our users love, we'll continue to extend the cloud interface to include more visibility to operators so they can better understand things like audit logs and connected clients and things like that, as well as to sort of the core buyer persona, right? The people who are managing spend and resources and things like that. Separately from that, we've been building an IDE integration in VS Code. So originally, we had built a language server protocol. So LSPs have become a common technology for exposing language services to editors, things like autocomplete or go to definition, features like that. And so we wrote an LSP for the Flux language and integrated that into VS Code. And over the last several months, we've been extending that core experience with the ability to also create and author tasks and do some sort of builder-oriented resource management within the IDE. And so while the browser is really intended over time to evolve to be an experience for both builders, operators, and managers, we really focus the efforts within VS Code solely at the developers who are building services, and we'll continue to invest in that. And by the way, the LSP that backs VS Code is the same LSP that runs through the browser, and that you can use kind of in the editor to get smart Flux completions there. So it's really, really fun to see those technologies and kind of how they can be deployed in different shapes and sizes. So next, let me see. Nope, that's still not correct. So next, we have the CLI. Maybe we can I think I might just talk through these slides. Maybe I'll just give this presentation verbally or we'll see. Okay, I guess we're on a CLI slide. I really apologize for this slide ordering. So at the CLI, these are tools that are really intended either just to get set up for people who really prefer terminal experience or so that you can build automation around some of these activities. We recently packaged the CLI into its own repository and into its own downloadable asset. So at the beginning of the year, if you wanted access to the CLI, you had to download the InfluxDB open source database, and then you could extract the CLI from that. Now, however, you can download it directly from the website. Or if you're me, you might just brew install it. It's typically how I tend to install a lot of our tools when I want to use them. And so we'll definitely continue to invest in the CLI. Underneath the covers, the CLI is essentially a wrapper on top of the JSON API, but it does provide a lot of high-level tools and some reasonable help to help you navigate the product and to build some automation around it if that's easier in your case than calling an API directly. So finally, the kind of final view that you can see are client SDKs. And so in this case, we've been authoring a large number of SDKs to allow you to integrate your application into our V2 API compatible products, which includes OSS2 and the cloud product. And so you can see that there's a large set of language-oriented SDKs so that you can kind of quickly create the integrations that you want. Of course, it's possible simply to call the API directly. And so there's a resource API that sits within, of course, that's served by the product. Is all of these other products are largely, or all these other user interfaces are largely built on top of this API. You can use it directly yourself. As an example of that, Rick Spencer, who's our VP of Platform, wrote an Android app that he calls Gigawatt that allows you to like write some simple queries, see some dashboards, and see checks that might run. And so Rick wrote this relatively early in the year and has used this so that he can make sure that cloud is in a healthy state. So it's a great example of an application that you could write on top of the API. And we see a lot of users who want to produce their own presentation layer for their own application. And so this is an example of that. This application is open source. There's a link here. If you go to GitLab, Rick Spencer 3 and Gigawatt, it's both a great example of, I believe it's written in Flutter, of how to use Flutter through the API. And also if something you'd like to extend yourself, I'm sure Rick would be happy to see any contributions, but it's something he certainly built and uses personally. And it's a great example of building directly on top of the API. So having talked through sort of the kind of the user-facing side of the product, let's talk a little bit about what is under the covers. So there's really two core components to the cloud product. The first is a product that internally we call Quartz. This isn't something that's directly exposed to users, but it's a really critical portion of our cloud product. And so Quartz is really responsible for a lot of the sort of commercial, including the free tier user journey. So it's what integrates users to our identity services. It's also what integrates users to our marketplaces. So you can sign up and use the cloud product through the AWS or GCP or Azure marketplaces. It's something that allows you to retire any revenue commit or any spend commit you might have to those marketplaces, or to consume credits that they may have given you to build something. Quartz also is responsible for coordinating a lot of the product analytics pipeline. And so we've built a rich analytics pipeline that helps us observe how users are using our product in order for us to make sure that we improve what needs to be improved. And Quartz has a key role in providing a lot of that analytics output. So Quartz runs as its own application and its own Kubernetes cluster, and essentially runs, kind of think of it as sort of a singleton. And so it sort of sits outside of the core regions that are doing data management and provides the user management, sort of user journey data backing and model and control tiers for that. Then the core product that you might think of as the core TSDB actually runs in a region-oriented model. So it runs in the three major cloud providers, and it runs within multiple regions of those providers. And so within those regions, we're using Kubernetes as sort of a standard substrate to try to provide some uniformity so that we can build relatively efficiently build a product that runs in these different cloud providers. I would say that that's been generally successful for us. We've certainly had a lot to learn about Kubernetes, and building a stateful multi-tenant database service inside Kubernetes, feels that we were quite early in that process, and we've learned a lot about it. So let's talk a little bit about what sits within each of the cloud service provider regions. This is obviously a very simplified view, but it's a little bit of a sketch that I can use to talk through, I think, some of the major components. And I think I'll just talk through these sort of from the top down. So within the kind of the API gateway tier, we actually run three different instances of the API gateway. So we run an instance that services the core write APIs, the core query APIs, and then an instance that serves a lot of the metadata APIs that exist. And we do this in order to provide sort of fault tolerance between these APIs so that if something aberrant happens, it makes one portion of the API unavailable. That we continue to have pods or services that are still servicing the other portions that are unimpacted. And that separation of concerns has been a really helpful change to us. Is certainly something that we've come to rely on. And so there's a fair amount of logic that sort of sits at this API gateway. And as I mentioned, we've been able to sort of isolate it into a number of core components. So underneath that, if you submit a query, for example, there's a whole set of query technologies that are also running behind that gateway. So we run a set of pods that exist to service Flux queries and another set of pods that exist to service InfluxQL queries. Some of these, for example, the InfluxQL pods maintain a group cache to allow the acceleration of various metadata queries that need to be made. One of the disadvantages from our point of view of having a schemaless database is that metadata queries are often difficult to serve directly from a static catalog, like might be common in a SQL system. However, we've found relatively effective ways to cache a lot of that data so that we can still provide accurate and fast metadata responses for InfluxQL, even though we might have to search the TSDB to assemble some of those responses. We spent a lot of time and have gone through a lot of iterations trying to find the right balance of process and tenant isolation within the query tier. The moment, kind of the current architecture here is that we are running each query within its own process space. We'll have many processes that are really being run within a pod. And then within that pod, we sort of have a process manager. And so we've spent a lot of time trying to navigate some of the various sort of like maximum pod budgets that are enforced by the Kubernetes control plane with our desire to make sure that user queries are running in an isolated and fault-tolerant environment where they can't impact each other, either because of a panic or just because of resource contention. So a lot of effort's gone into that. And I think the query tier is really sort of taking shape nicely over time. On the right side, so when you write data to the API, that data, of course, gets parsed and validated and authorized and authenticated, and then it gets written to a set of Kafka topics. So while the query tier is relatively heavily isolated at a process level, the storage tier is a little bit more of a shared resource. So within cloud, the storage tier is, in most of our regions, partitioned across 64 sort of, you can think of them as kind of like virtual databases. And each of those is replicated once for a total of 128 core data nodes that are running within the storage tier. Those nodes can be mapped to a smaller set of physical resources. And just recently, that mapping has become dynamic so that we can both scale up and scale down the storage tier within a region in a fully automated way without manual operation. So you write data to the database, it lands in a Kafka topic. Those topics are aligned to the storage partitions, and then there are basically a process per partition that's reading that data out of Kafka and writing it into the storage tier. And so essentially all data manipulation flows through that path, whether it's writes or deletes. As the TSM engines are running, they are producing their usual tiered LSM tree style compactions. And at some point, they write their compacted files, they write their compacted TSM data to S3, and so, or to the object store within the service provider that you're using. And so that object store really becomes the durable long-term backing of the data in the system. And so the top of the system for data that hasn't reached S3 yet, that data is durable in Kafka. And for data that's been compacted, it becomes long-term durable in the TSM store. And then the storage tier itself has what's essentially full cache of the TSDB in typically in EBS volumes or in whatever attached block system is. I wish the different service providers used the same names. It would make it easier to talk about this, but hopefully you know what I mean. Separately from that, as data is arriving and written to Kafka, we actually archive that incoming write stream separately from the long-term TSM store to another set of object store buckets. And so this provides us sort of a just-in-case backup in addition to the replicated backup of the actual core TSM files. And we've used this in a couple of different cases. We have used it, I believe, in at least one instance to recover a durability event, but we've also used it operationally to help users who, for example, deleted a lot of data, perhaps they didn't intend to delete. So it's been really helpful. So overall, within the storage tier, we actually maintain 3 durable sets of your data. We maintain the full copy within the object store post compaction. We maintain an offline backup, you kind of think of it, or a nearline backup in this line protocol backup. That's the ingest stream. And then we also have a copy that we don't really rely upon for durability, but that we use to accelerate time to recovery on the EBS volumes where these individual partition managers are running. So that's a little bit about the storage tier. And then finally, and very importantly, we've been moving towards more of a microservices model for some of the core UI services. And so we've been slowly extracting more and more API endpoints out of kind of what was this more monolithic gateway structure into individual services. So for example, the maps feature, the notebooks feature, the annotations feature, all of these are backed by small services that are just a little bit easier to manage, and that also allow us, kind of going back to the shape of our organization, just allow us to empower our front-end teams to own deeper and deeper portions of the stack so that they can just build the best integrated sort of front-end and API possible. So that's a little bit kind of about what's under the covers for cloud. I hope that gives you a little bit of a picture how we use sort of courts sort of separately for user and organization management and user journey management and marketplace and billing integrations, and then how within each region we have another kind of instantiation of the product that manages the core query and storage and UI services that are necessary. So I mean, that's great. I want to talk a little bit about how we build and how do we operate that. So let's kind of work through that a little bit. There's really 2 main points here. One is building and one is operating. So from a building perspective, we run a continuous delivery model. It was really important to us when we built our cloud service to be able to deliver improvements to that service in a very incremental and continuous way. And so most weeks we deploy new code to cloud somewhere between 20 to 40 times a week. So we feel that we've really succeeded at that goal. It hasn't been easy, and we've done a ton of work to get there. Our teams work in a relatively typical 2-week sprint model. We try to organize 3 sprints or 6 weeks or 45 days kind of into a theme, and then let teams go off and sort of like build in 2-week iterations. On the operating side, we have an owner-operator or a DevOps model where the teams who build services are primarily responsible for running and executing them as well. So let's talk a little bit about the work that we've done to get code from sort of point of being authored and tested into production. And so this is really the primary responsibility of the team I mentioned earlier, sort of our developer ergonomics team. Internally, we call them our deployments team, but they've become responsible for more than just deployments. So we've built a really nice pipeline, a really nice CI/CD pipeline. So to commit code to our cloud product, really all you need to do is have a code reviewed, approved, and fully CI'd PR that gets merged to master, to trunk, and Git. And from there, there's a bot that will pick up that merge, that will fast forward it to the tip of master, that will run it through another CI process, or through the CI process again. We use Circle CI to manage that as our test runner. As artifacts emerge from Circle, they get picked up by Argo CD, which we use essentially as our deployment orchestration tier. Argo will then deploy those changes to individual staging clusters. So we run a staging cluster, a pre-production cluster in each of the CSPs, because there is some CSP, there is some service provider specific code, especially at places like the storage tier. And then if you successfully pass through the staging tier and pass a smoke test there, then the code will be sequentially rolled out to production. We have essentially a big red button internally that anybody can push to kind of stop the line on this, but most changes, the vast majority of changes are successfully deployed in this fashion, and it's just a really fully automated system. It's very, very cool to be able to get code to a production user simply by hitting the merge button in GitHub. And it's just a tremendous amount of effort that's gone into building a reliable and trustworthy system like this. Part of that effort has been making the CI and the CD process observable. And I'd like to talk about some of the internal tools that the team has written to do that. So the first thing that's been produced is a tool that we call Glance. And Glance allows you to see where a PR is sort of in this pipeline across the many different regions and clusters and staging clusters that we run. I believe something like 12 environments, roughly, that a change needs to be rolled out into. It might be 13. I keep thinking of more, maybe it's 14. Anyway, there are many environments that a change needs to be rolled out to. And so it's really important that we can understand what changes are where, both in production and in test environments. And so we run this tool, or run this tool called Glance internally that allows people to see that within the organization. Separately, our goal is to be able to go from PR to production in 20 minutes. We're not there yet, but we're working hard at it. And to make that a more introspectable process, another tool has been written internally that we call Pipescope that allows us to collect lots of events from the entire CI/CD pipeline and then present them as traces that we can visualize in Jaeger, which is really cool to be able to look at an end-to-end distributed trace of the entire CI/CD environment. It's really helped us understand where we're spending time in our path to production and to figure out how we can continue to improve the internal developer experience within Influx. So then after that, we also have a set of tools that we try to use to make it easier to write code internally. So I've talked a lot about how code gets deployed, but authoring code within a Kubernetes environment is really quite challenging. And so we've gone through a lot of iterations of this. I think that we have probably built, 5, maybe 6 different ways of trying to run the full stack on a laptop. And we finally kind of gave up on that, to be honest. So as the Kubernetes product grew and expanded, it became more complex. It just had more parts to it. It just becomes harder and harder and harder to be able to simulate that environment for a developer who wants to write code, especially if you're working sort of relatively high at the top end of that stack, and you need a lot of lower level services, right? Kind of the higher in the stack you're working, the harder it becomes in an interesting way. And so we've moved to what's often termed a remocal model. And so we're using a set of products. We run a Kubernetes cluster that essentially any developer can create a namespace in. That namespace is then populated through automation with the full stack or nearly the complete stack. And then people can simply use that from their laptop in a really seamless way. So you can, for example, be doing UI development on a laptop. You can have your assets and the TypeScript, HTML local, and essentially there's a daemon that runs in the background that will package and push that to a namespace and allow you to get a very seamless development environment. I'd say these tools are very new. The experience is still a little bit rough, but this is by far, I think, the best way forward for us. Still not always a joyful experience writing code for a complex Kubernetes environment, but if this is something that you're struggling with, I would definitely suggest looking at some of these remocal tools. They've been relatively successful for us, and I think where there are still some rough edges, and there are still some very rough edges sort of in these stacks, I'm actually very optimistic that they'll improve over time. And so I think this is a nice way to try to get some some scale and velocity and some better builder experience internally. From an operations perspective, as I mentioned, we have essentially an owner-operator model where users or the development teams are responsible for their services. We just manage this in a pretty straight-ahead way. We have PagerDuty teams and PagerDuty rotations and some triage tiers, and then the usual sort of pager escalation models. We do pay attention to things like total pages per month and set some error budget like kind of goals around that. Yeah. The other thing that's interesting about Influx is, unlike a lot of products, we have a lot of nice ways that we can dog food, or if you're Tim, our VP of product, drink your own champagne, the products that we build. And so we use a lot of Influx to build and monitor Influx. We've also built a really nice Slack-based incident response process and have used some tooling that's made that a little bit easier. And yeah, I'd say all of this is working pretty well. We, like many other people, use Status.io. You can subscribe to status events or operational events here. And so if you're using Cloud and you'd like more information on its operational status, just a plug here that if you go to status.influxdata.com, you can subscribe to email or webhooks or whatever to get operational events. And part of our incident process is making sure that this status page is up to date. That's a little bit about how we run the system. Great. So let me kind of pivot next away from cloud and talk a little bit about some of the other work that we've done throughout the TIC stack. I'm just going to kind of walk through these component by component. So within Telegraph, we've done a lot of work to sort of scale our Telegraph team. I think the Telegraph team is larger now than it's probably ever been. We also recently split some of the functional work in Telegraph out. So we had some folks in the Telegraph team who are also working on writing some cloud services, and we've separated those out so that we can just provide a dedicated team to Telegraph. Telegraph continues its quarterly release process and I feel like is running just really smoothly, and is, I think, by far our most successful open source product that we produce. We also made a really nice step this year in that identified some really core community contributors and have given them commit rights and PR review rights for Telegraph, which is something we'd love to do with some other products, like especially Capacitor. But we've started this first within Telegraph, where I think we just have the healthiest community, and it's really been quite successful. And so I think Telegraph is in a good place. On Flux and on InfluxDB, so there's, of course, two flavors here, 1X and open source 2. Internally, we have built some software lifecycle work so that we have a way of picking up changes that land in cloud and getting those merged and shipped to OSS 2 on a regular basis. It was quite a bit of organizational work to do, but it's a process that's running really smoothly now. We'll be planning on producing monthly releases, starting with 2.1, which is available now. And so, as Tim was talking about yesterday, we are currently shipping our software to cloud, where we can feature flag it and test it and explore it and do user testing and observe its use, right? Take that feedback, refine those features, and then we're pushing those features essentially downstream to open source Influx 2. And then trying to get those to you on a monthly basis so that OSS 2 stays closely in sync with the capabilities of our cloud product. On the chronograph side, so existing chronograph users can leverage the compatibility APIs that exist. So there are V1 compatibility APIs for cloud so that you can use the V1 products for write and query against that. Also, chronograph recently learned how to allow you to set up V2 auth. So now when you configure a data source in chronograph, you can just do that more naturally to the V2 APIs. Chronograph 1.9 is our latest chronograph release and includes significant improvements to the log viewer, integrations with Capacitor for Flux-based Capacitor tasks, and some operational improvements such as the ability to pause the active queries list and set a refresh interval, things like that. And so just continuing to kind of work at Chronograph and also going pretty well, I believe. And then finally on the capacitor side, so we have open sourced most, I think all of now the enterprise capacitor authorization features. So we've moved those into our open source capacitor product. We have taught capacitor how to execute flux tasks. So now you can not write tick script if you choose, and instead you can write flux, and capacitor can use those flux-based tasks. That's tricky to say quickly, exactly like it could a tick script task. Also, if you would just like to use a Flux query in a tick script task, you can do that with a Flux query node. And so we continue to invest in capacitor. A lot of our most passionate users are capacitor users. It's really cool to see the things they build. And we hope that continuing to integrate capacitor into the Flux and other technologies that we've built will just continue to improve its utility for you. Finally, we get this question a lot. I just want to kind of take a moment just to, really clearly reiterate our commitment to our kind of non-cloud, on-premises commercial software. We have made substantial investments in teams and processes. We continue to ship all the components of the tick stack on a regular basis. And we've made some really nice kind of deep technical improvements to core database systems like hinted handoff and the anti-entropy system. We've added capabilities to InfluxQL for things like show tag keys with and show measurements within a retention policy. We have what looks to be some really promising TSI memory footprint and performance changes that we're testing now within our cloud managed database offering. And if those continue to show the promise that we've seen early, we're really excited to get those to you. And so we just really continue to invest and execute. We are absolutely committed to continuing the advancements of these features and capabilities without any significant change to the deployment footprint that you're used to with the enterprise product. And so with that, I believe I have roughly 8 minutes for Q&A. So let's get started. Let's see, how can the community improve documentation in terms of installation, configure operation, updates, etc.? All of our documentation is open source, and so most of it, I believe, has a contribute or like a file a bug. So there's two ways that you can help documentation. You could go to the documentation repo itself and propose a PR, or anywhere that you find documentation that you think is insufficient or that didn't answer your question, you're very welcome and encouraged to file a defect report to that effect. We actually have a fair amount of analytics on the documentation. So we look at least for search results that happen within our doc search capability, we look at search results that don't receive answers. We look at pages that get heavily viewed. And so we try to understand which portions of the documentation are being used and which portions are insufficient from an analytics approach. We've also have just put more talent resources, more people. I try hard not to call people resources. It's a horrible managerial mistake. But we've worked hard to expand our documentation team. So for example, someone recently joined our team to work on API documentation. And so we definitely are excited about where the documentation is going. There have been some really great improvements to things like the Flux documentation. You can now see input and output examples. Those are actually going to be fully integrated into the Flux build and compile process so that all those examples will get tested every time we release Flux. A lot of cool things happen in docs. But if you'd like to help, you could either file an issue or you're welcome to file a PR itself with a direct improvement. What are the plans for retrofitting GUIs from cloud to enterprise? So that's a really good question. We really approach this from an API perspective. So we will be unlikely that we'll port the entire 2.0 UI experience to the enterprise product. However, the enterprise product does support the full Flux experience. and the cloud product supports the full V1 experience. So really, we focus a lot on being able to have an application that can run across both of these capabilities. But if you have a more specific question about, I think the only real tool here that doesn't really quite work would be the Cloud 2 UI. Yeah, let us know kind of more specifically what your question is, and we can connect you to a better answer than perhaps I've given here. Do we support bug reports from free InfluxDB users? Yes, we do. I will acknowledge openly, and I've talked about this in other times that I've spoken at Influxdays, we receive a lot of GitHub input, and I am well aware that there are sometimes issues that get filed that are not addressed perhaps as well as the community would hope. We do have a finitely sized team, and we are vastly outnumbered by our users. We do our absolute best to triage and identify issues that are that represent either durability or security or correctness risks, and we get those addressed. But we answer and respond to a large number of bug reports from free users. Definitely file those to GitHub, and we do read them and triage them. Are we hiring? I don't know who asked that, but absolutely we are hiring. I don't know how, I don't know exactly how polite it is for me to solicit our community, but we do hire from our community. One of the really cool things about working at Influx and hiring within Influx are the number of people who come to us familiar with the tools we make and really passionate about them. And so if that describes you, we would love to see a resume. We have a careers page that lists sort of where we hire and what we're currently hiring for, and definitely would encourage you to check that out. We're hiring throughout the entire company, not just within engineering, but also doing a lot of hiring within sales and marketing, sales engineering, support. So check it out. There could be a spot at Influx for you. Are you planning to open source Glance and Pipescope? Yes, I'd love to see these open source, or at least the Pipescope tool. I really a decision for the team that builds it from my perspective. There's nothing there that I would consider proprietary and not openable. So I'll certainly ask the team if they'd be interested in that. I know they've talked about it a little. Yeah, certainly encourage them to do that. What are the engineering team's big challenges or projects planned, and how can community people get involved? That's a good question. So we have a lot of ambitious plans for next year, and they are pretty expansive. So we absolutely want to continue to make progress at building a really first-class builder experience within the web UI. As I mentioned, there's a lot of work that'll continue to flow into InfluxDB and Telegraph and Capacitor and Chronograph. We also have a lot of thoughts about how we can better use sort of our region deployment model to offer users a little bit more flexibility in how they can create accounts in organizations within cloud that can span regions. Um, I think the number one way to help as a community member is just to share a little bit about what you're building, right? One of the biggest benefits of having a strong open source community is, I say there's like really two primary benefits that I see from my perspective. One is we just kind of get this intimacy of what you're building. We get to share in your enthusiasm in that, and we get to learn about where the product works well and where it works poorly. And so just continuing to kind of create that connection is a really critical input to us and what to do and what to build. And then secondly, I mentioned that time series is very much about ecosystems, and it's just impossible for us to be experts in all parts of that ecosystem. And so another key way that the community contribute is by sharing their expertise in areas that are sort of adjacent to the core time series database in many ways. And so I think Telegraph is sort of the exemplar of this. There are so many plugins in Telegraph that are well beyond our expertise, right, where we really rely on the community to understand what's the best practice, what's the critical information to be collected or published. And so there's that's another great place that in a way that you can help is just by sharing the things that you know that we don't know, right? And there's plenty that that we don't know. I'll be the first to admit that. So, gosh, what feature or current development am I personally most excited about right now? Uh, that's a fun question. Part of my responsibility, however, is representing all of our Influx engineering team, all of which does great work. And so I think I may not state my personal preference here, because really the point of my presentation today is to share the work of the entire team that I'm lucky enough to be part of. And so I don't think I'm going to call out favorites, because I feel like that would really be a disservice. So will you continue to support read and write InfluxDB 1x APIs? Yes, absolutely we will. They've been integrated into the 2x products. They're there to use. Absolutely, they'll be supported, and there's no plan to deprecate them. They'll be supported for a very long time to come. And then finally, with the planned monthly release, it should be good to invest time and resources to increase stability, reliability of products, and implement deeper validations and integration testing between the products. Yeah, it's always possible to test more, for sure. We've been building, our focus lately on testing has largely been around performance testing. And so we've built a number of performance test harnesses so that we can, for example, compare relative performance of Flux and InfluxQL queries in OSS2. We've also spent a fair amount of effort building out performance test harnesses to better find performance regressions in the on-premises products. So we definitely agree testing is a forever activity, and we do continue to build out improved testing infrastructure within Influx. Well, with that, I think I've come to the end of the questions and also the end of my time. Thank you so much for the help. I apologize for the confusion with slides. I hope you were still able to follow, and thank you for the people in the background who got that fixed for us quickly. Appreciate it. Back
Ryan,
to
that
you,
was
Chris.
amazing. That was really great. I mean, it just shows. I mean, there's a couple of things that I want to highlight. I think the amount of work that the team is doing is really impressive. I also think that myself and the community agree that not only are you committed to building these great open source projects, but sharing how you and the team are taking those open source projects and using it with InfluxDB Cloud and sharing how you're actually building that. I think that's really, really wonderful. And I'm speaking on behalf of the community. They appreciate it because they're also building some really phenomenal SaaS applications using InfluxDB. So I think great sharing will lead to really great products from everybody, not just from us. So thank you so much for that. And yeah, I want to also apologize about the little bit of a flub we had with the presentations, but my commitment to everybody is that when we do the edit to the video, we'll make sure that all those slides line up in the beginning. So when you take another look at it, everything will be cool. But it's still an amazing presentation regardless.